All right, this is the third installment of the review. It says simplify the expression using the fractional exponent, the fourth root of x. Notice that the exponent of this is 1. So therefore, we can use our rational exponents rule here on this sheet, where we are told that if we have x to the 1 over n is equal to the nth root of x to the 1. So if we can do it one way, we can do it the other. So we can basically note that this 1 is going to be our numerator, and this 4 is going to be our denominator when we write it as a fraction, so that it is x to the 1 divided by 4. And that's our answer. For the next problem, we have something similar, where we have x to the 2 over 5. And it says simplify this expression using radical notation. So now we're going to turn it into a radical. Remember, we just said that our numerator is the exponent part of our radical, and our denominator is what we call the index of our radical. So we have this radical, our base is x, our index is 5, and our exponent is 2. And we're done with it. For this next one, we're going to do the same type of thing. It says simplify this expression. We have the cube root of x to the 12th. Remember, our exponent is the numerator. Index is our denominator. So we can rewrite this as x to the 12 divided by 3. Twelve divided by 3 is 4. So this is x to the 4. The next problem says write the formula for the nth term from this given sequence. So we have 1, negative 3, 9, negative 27, and 81. Now, it says in the nth sequence, let's forget about the fact that the answer is there. Key thing is saying is write the formula in the nth term. So that means we need to write an explicit form, which is a sub n equals a sub 1 times r, which is our common ratio, raised to the n minus 1. A1 means the first term of the sequence. R is the common ratio given by taking, for instance, A2 divided by A1. A2 divided by A1 is negative 3. And our first term in the sequence is 1. With this information, we can plug it into our explicit form, so that we have a sub n equals a1, which is 1, times our common ratio of negative 3 raised to the n minus 1. And this is our final answer. The next one says write the formula for the nth term of the sequence. That means we're going to be writing this in explicit form. And here's a reminder of what that is. Make sure you have that in your mind. A1 is 4. Our common ratio we find by taking our A2 and dividing it by our A1. So that's 20 divided by 4, which is 5. So when we write our equation, we have a sub n equals a sub 1, which is 4, times our r, which is 5, raised to the n minus 1. All right, the next problem says a sequence can be generated by using the formula a sub n is equal to 4 times a sub n minus 1, where a1 is equal to 10 and n is a whole number greater than 1. What are the first 4 terms in this sequence? Well, first off, a sub n equals 4 times a sub n minus 1 is the recursive form, basically like our now next, how we go from one term to the next. So if we start out with a1 being 10, to go to the next, we need to be multiplying it by 4. How do we know that? Because 4 is our common ratio. So 10 times 4 gives us 40. So the first term in the sequence is 10, then comes 40. How do we find out what comes next? We replace the 10 with 40, and 40 times 4 is 160. And then 160 times 4 is 640. So these are the first 4 terms in the sequence. Finally, we have another problem similar to the previous one, where we're given a sub n is equal to 0.5 a sub n minus 1, where a1 is 32, and n is a whole number greater than 1. a1 is 32, and we're given this formula. This is recursive formula, basically like our now next rule. So we need to take 32 and multiply it by this common ratio of 0.5 to get our next term. So 32 times 0.5, or a half of 32, is 16. And a half of 16 is 8, and a half of 8 is 4. So our first 4 terms in this sequence is 32, 16, 8, and 4.